Yeah, one of those article videos again. Physics.org stumbled across this one. Astronomers capture black hole eruption, spending 16 times the full moon in the sky. A black hole eruption. Recently we had 75,000 bright black holes. Centaurus A is a giant elliptical active galaxy 12 million light years away. At its heart lies a black hole with a mass of 55 million suns. This image shows the galaxy at radio wave lengths, revealing vast lobes of plasma that reach far beyond the visible galaxy, which occupies only a small patch at the center of the image. The dots in the background are not stars but radio galaxies, much like Centaurus A, at far greater blah blah blah. See, pinch. That's a Birkeland current. Which goes like that. In a way, I missed a bit. And here we have the C pinch. C pinch. So now let's read a bit about that. Astronomers have produced the most comprehensive image of radio emission from a nearest actively feeding supermassive black hole to Earth. The emission is powered by a central black hole in the galaxy Centaurus A, but 12 million light years away, as the black hole feeds on infalling gas. It ejects material at near light speed, causing radio bubbles to grow over hundreds of millions of years. You know, like if you just take common sense and try to understand what they are and try to explain you, it doesn't make sense at all. It just doesn't. When viewed from Earth, the eruption from Centaurus A now extends 8 degrees across the sky, the length of 16 full moons laid side by side. The research was published today in the journal Nature Astronomy. Lead author Dr. Benjamin McKinley from the Curtin University node of the International Center for Radio Astronomy Research, ACCREATION, said the image will reveal spectacular new details of the radio emission from the galaxy. These radio waves come from material being sucked into the supermassive black hole in the middle of the galaxy, he said. It forms a disk around the black hole. As the matter gets ripped apart, going close to the black hole. Powerful jets from either side of the disk, ejecting most of the material back out into space to distances of probably more than 1,000,000 light years. Really? Powerful jets form on either side of the disk. Really? So that's a black hole. And if you see it from the side, it's a disk and it has jets coming out of both sides, or maybe they are coming in too, because we have a Birkeland current. Previous radio observations could not handle the extreme brightness of the jets. The extreme brightness of the jets from a black hole. Does this make any sense to you? It doesn't to me. And details of the larger areas surrounding the galaxy were distorted, but our new images overcomes these limitations. We can learn a lot from Centaurus A in particular just because it's so close and we can see in so much detail, they said. Now, Astrophysicist Dr. Massimo Caspari from Italy's National Institute for Astrophysics said the study corroborated a novel theory known as, hold your seats, chaotic cold accretion, CCA, which is emerging in different fields. What? Birkeland currents. It's just so amazing that in this model, clouds of cold gas condense in the galactic halo and rain down onto the central regions, feeding the supermassive black hole, he said. What? I don't know. That's BS, I would say. But I went to shop. I went to the shop today and I saw something which reminded me immediately of Birkeland currents. Birkeland current in the snow. No, it's not really. But anyway, I couldn't. I had to stop and take a picture. Actually, we should listen a brief moment to Donald Scott.
And those last two are very difficult, believe it or not, to ionize. I guess because they have very few electrons to ionize. But it's easy to ionize iron. And so you find iron at the center of this thing. So his discovery that there is indeed a band of hydrogen-rich stars on the outer edge, is again confirmation that this thing is a Birkeland current, because Markland predicted and saw that hydrogen goes to the outside. It has nothing to do with the age of the stars. The reason he says they're young stars and that formed last, that's the astronomers, I think, incorrect stellar model. There's nothing that says that a hydrogen-rich star has to be younger than a carbon-rich star. So it was kind of interesting, I thought, that in his, of course, his explanation of this stuff, but when we tried it, it doesn't work. So the only thing left is gas comes from someplace. The little green people come and pour it in, but they really have no explanation for this. It's kind of like what Jim said last night. Here is that, I'd like you to make sure you understand what's going on here. Let's see if I can do this. Yeah, I got the wrong thing. I just wanted, well, I'm playing around with this. I shouldn't. The X shape that you see there, the star grouping that's in magenta or purple, is, if you notice very carefully, what we got plotted here, the upper half of that plot is where the light is longer wavelength. So the wavelength is on vertical, and it's plotted. If you can read it, it says velocity in kilometers per second. So they're saying that the redshift is proportional to velocity. That doesn't contradict Hall and ARP at all. ARP is perfectly willing to say that redshift can be caused by recessional velocity. It's not the only way to form redshift, but it is one of the ways. So they're right in this case. And
Yeah, I don't want to talk on top of him because he knows much better. But anyway, this wasn't particularly about the Birkeland current itself, but about the redshift and about how they are like trying to figure out how far off away something is by the redshift. But it's somehow funny and interesting that the article I was reading before uh, came out yesterday, and this video, for example, is 4 years old. How they just still don't get it? What the knowledge the peer-reviewed science and all the stuff is there, available, freely, for everyone. What's the problem? I don't get it, you know? And people still are reading about this kind of really odd things, supermassive black holes, and what was it again? This new theory I have never heard of. And I have to admit, when I was reading that for the first time today, now it got mixed up the whole. Here it is: chaotic, cold accretion. So, do you really think that the universe and the stars, planets, we, and everything just is a real chaotic happening? Just everything happens really totally randomly? That every move you make needs this kind of electrical trigger, like in the muscles? Every heartbeat is an electrical impulse. Every thought that you have is electromagnetic impulses interpreted by your mind. Lightning bolts from the sky, so there has to be a huge amount of electricity in the sky always. It just doesn't make sense when they are trying to explain in this way things. And they can't. They don't explain anything. They just figure new stuff out. A novel theory known as chaotic cold accretion. Doesn't make sense to me. I will leave a link below to the video we just watched a bit, Donald Scott. Learn about Bertrand currents, and you will be ahead of NASA and all those people immediately. Thanks. Bye.